Okay, so we've seen some examples already where we've had to use the chain rule or the product rule, quotient rule, etc. What I want to do now is one that's a little bit trickier in case you come across something like this. What we've got to spot here as well, we have to be able to differentiate this. We have to differentiate sine of x e to the x. And I think the first thing I would say is we have a function inside the bracket which is inside the sine function. So it's a function of a function. So it's a chain rule question. However, our innermost function, x e to the x, well, that's a product. So we've got a product that's sitting inside a chain rule question. But the big picture is this is a function of a function, so we're going to use the chain rule. Now the first thing we do with chain rule is we say we need to do a substitution, let u equal something. And the general rule is that it's the innermost function, the bit in the brackets. So the bit in the brackets in this case is x e to the x. So we have our substitution, and then what do? We rewrite y. We rewrite it with our substitution in place to make it a bit easier. So we have sine, this time it's sine of u because the bit in the brackets has now become u. Okay, so we have u and we have y. Again, inside our chain rule template, what do? We differentiate u with respect to x, and we differentiate y with respect to u. And if you've done a few of these before, or if you've seen the sort of nicer examples on the chain rule, you'll be aware that the solution we're looking for, the derivative, is just the multiplication of the two answers that should wait for us here. So, I'm trying to find dy dx. And the easiest way for me to remember this formula is to split up the dy dx like this. And in the gaps, I use my du. So I'm looking for the product of these two terms, which would be my two answers on the right of the board if I can find them. Let's do the bits that are relatively nice. If I come to here, I have sine of u, and if I differentiate that with respect to u, I would get cosine of u. If I come to here, if this was a nicer question, I would just be able to differentiate this, and I would say my final answer is just this solution times cosine. However, when we see here that we have a product, so to find this answer, I have to be able to use the product rule. So I'm going to use a bit of space down here. I'm going to squeeze down here. I'm going to treat this as a brand new question. So what I'm going to say is, I just want to solve this. I want to solve the differential of x e to the x. So I'm going to go through this quite quickly because you will have seen some of these examples before. If I differentiate this product, I have the first term multiplied by the differential of the second term plus the second term multiplied by the differential of the first. And if I tidy that up, I will have e to the x as my common term and x plus 1. So I've gone through that quite quickly, but that term there, that is differential of u. So that's my solution to go up here. So it's e to the x, x plus 1. I've set the template out as if I'm doing a chain rule question, which I am, and I've dealt with the tricky bit, which was my product with inside of a chain rule question. So now I can just rewrite it out. So from here I can see my dy du is cosine of u, and my du dx is e to the x, x plus 1. I mustn't leave the u in my final solution because there was no u in the question. I put that in to make my life a bit easier. So I tidy up by saying what is u, and it was x e to the x. And we have our solution, like so. Now, this method here can work lots of ways around. If we have a quotient rule inside of a chain rule, or a product inside of a quotient rule. So what you need to do is bring all your skills that you've practiced for chain, quotient and the product rule and see if you can use them when perhaps you have to do two in one question. Okay, thanks for watching.